All right, so today's topic is 1-3 algebraic expressions. Make sure at the top of your page goes your name. You include me as your teacher. The class is Advanced Algebra 2, today's date. And our learning objectives for today are to evaluate algebraic expressions and to simplify algebraic expressions. It's just one simple step closer to solving equations, which is coming up in your future. Okay, so essential understanding for this section, and we want to make sure we get this before we hop out of 1-3. You can represent some mathematical phrases and real-world quantities using algebraic expressions. So we're converting English language into mathematical algebraic expressions. So what we're going to do here is we're going to write an algebraic expression that models each word phrase. So in your notes, you don't have to write the whole, you can summarize this little instruction. So you can put algebra or words to algebra, but you definitely need the words that are written right here. So you write on your paper 4 more than a number B. Rule of thumb that I use, anytime you have the word than, you switch the English order. So 4 more than a number B, I would write as B plus 4. The reason I do that is because when you have the words less than, you need them in the reversed order. So I just apply that rule. Even though 4 plus B is also correct, I use the, if you see the word than, switch the order of the sentence structure. The product of 8, product means times, and the sum means plus, of a number x and 3. So we're going to take 8, we're going to times him by x plus 3. The quotient of the difference between 5 and a number n, so the difference between 5 and a number n, and it's going to be a quotient, so that's divided by, and 2. I would also accept the division symbol in 2. The rule of thumb that your book uses, you guys do not have to write this down, to model situations with algebraic expressions is identify the actions that suggest operations. Add, subtract, multiply, divide. What are we going to be doing? Define one or more variables, x, y, a, b. What letters are we going to use to represent? And then represent the actions using variables and operations. So put all that together. We know what operation we're going to do. We know what variables we're going to use. Now we're going to put them all together. All right. Jenny had $130, but she's spending $10 per week. So what is our variable for Jenny's situation? All right, so we have to use our 130. We have to use 10. And I'm gonna use W to represent the amount of weeks that go by. So we know she has $130 at some point, but that every week that goes by, she is spending, which spending usually means minus. Per week usually means times. So anytime you see per, I'm going to think I'm multiplying it by something. All right, the piggy bank contained $25. Make sure you're writing these example problems in your notes. And $150 is added each day. Oh, well, that's easy. So we're adding, we have to, $1.50. I said 150. So $1.50 is being added each day. It starts at 25. Each is like per, so I'm going to use multiplication there. I'm going to use D to represent the number of days. So the piggy bank starts out with 25. We are adding $1.50 each day. The last one, you have 250 minutes left on your cell phone and you talk an hour a week. So we definitely have to use 250. Are we increasing the amount of minutes we have on our phone or decreasing? Decreasing, so that means a minus. We talk an hour a week, but I got a problem here. I am in minutes, so I'm going to make that 60. I'm going to use W to represent week. An hour a week is same as an hour per week or hour each week. So we're going to do the same operation as we did in those scenarios and multiply. So we got 250 minus 60W. And by the way, the only way to get better at this process is to practice, practice, practice. So if you feel like I'm no good, I'm getting all these wrong, keep practicing, keep doing practice problems until you feel confident. All right, I am actually going to have you write this down in your notes. I want you to write down what evaluate means because we're just talking about an algebraic expression. We're going to evaluate an algebraic expression, which means substitute a number for each variable in the expression, and then simplify using order of operations. I actually want you to write this down. Go ahead and box or highlight the word evaluate or put a star next to it, just so you know why a random sentence lives inside of your notes. Oh, it just tells me what to do when we're evaluating. Because evaluate is something we will be doing a lot in this class, so if you don't know the terminology or what they're asking of you when they say evaluate, it could put you at a disadvantage, and I want you to be advantaged. All right, so the first example problem we're going to do is this big chunky one here. It's 4 parentheses 2m minus n minus 3 times 2m minus n. And we're going to substitute negative 15 for m and negative 18 for n. So everywhere I see an m, I'm going to replace it with a parenthesis negative 15. Everywhere I see an n, I'm going to replace it with a parenthesis negative 18. If you feel like, nah, I'm so smart, I don't need parentheses, I recommend you not doing that. It's especially with integer values. We learned about integers yesterday. Especially with integer values, it's hard to track everything if you're not putting parentheses around the appropriate items. So then minus 3 times 2 parenthesis negative 15 close parenthesis minus negative 18 close parenthesis close parenthesis. There's a lot of minus and negatives, and we want to make sure that we track all of them. Okay, so the order of operations say I'm going to do what's inside my parentheses first. Parentheses, exponents, multiply, divide, add, subtract. So I'm going to go 2 times negative 15, which is negative 30. Minus a negative is plus. 2 times negative 15 is negative 30. Minus a negative is plus. Nice. All right, so 4 times negative 30 plus 18. Tell me that it's negative 12. It's your last chance to tell me right or wrong. All right, so 4 times negative 12 minus 3 times negative 12. I'm going to do my multiplication. 4 times negative 12 is negative 48. Minus 3 times negative 12 is negative 36. Minus a negative is plus, so I get negative 48 plus 36. And I believe, tell me that's negative 12. All right, for the second problem, we're going to put in negative 5 for A and 3 for B. So it's 4 times negative 5 plus 7 times 3 plus 3 times negative 5 minus 2 times 3 plus 2 times negative 5. 4 times negative 5 is negative 20. 7 times 3 is 21. 3 times negative 5 is negative 15. Negative 2 times 3 is negative 6. And 2 times negative 5 is negative 10. Negative 20 plus 21 is 1. 1 minus 15. Negative 14. Negative 14 minus 10 is negative 20. Minus 10 is negative 30. Check my math. Did we do that right? So a term is an expression that is a number, a variable, or product of a number and one or more variables. Coefficient, the numerical factor of a term, it's the number on the front. Constant term, term with no variables, it's just the number, that's a constant. Like terms, they have the same variables raised to the same powers. They don't have the same power, so x squared is not a like term is not, and x cubed are not like terms. Okay, so I don't want you to write these down, but we're going to use these properties to simplify algebraic expressions. So we're going to use the property that a minus b is the same as a plus negative b. If any of these properties are new to you, like, oh, I didn't know that, please write them down. Definition of division. A divided by b is the same as a over b is the same as a times 1 over b. Distributive property for subtraction, same as distributive property. Everything on the inside of those parentheses gets multiplied. Multiply by 0, you get 0. Multiply by negative 1, you get the negative or the opposite value of your original. The opposite of a sum, so negative parenthesis a plus b is equal to negative a plus negative b, or negative a minus b. Opposite of a difference, so negative parenthesis a minus b is the same as negative a plus b, or those two guys flip, b minus a. The opposite of a product, you can write negative AB as negative A times B or A times negative B. So the negative can hop onto either value. And the opposite of an opposite is your original value. So negative parenthesis negative A is equal to A. These are inherent. Usually we do these without thinking about it, and we have this in our knowledge base because we use them often. All right, so here we go. Here's the beginning of our practice. We're going to write an algebraic expression to model the total score in each situation. Then evaluate the expression to find the total score. Well, I only put down one situation, so just for this one situation. So write this down. In the last baseball game, there were 2 3-run home runs and 4 hits that each scored 2 runs. All right, so we have a situation where we have 2 3-run home runs. So a 3-run home run, I'm going to call an HR. It's going to earn us 3 points every time we get one of those. So this is my work. This is just scratch. I have 4 2-run hits. So every time I got a 2-run hit, I had 4 of those scenarios. So I'm going to call a 2-run hit. I'm going to give us 2 points for each one of those, and I'm going to label a 2-run hit as H. So I've found a variable. In this case, HR and H are my variables. And then I'm going to multiply that by however many runs that gets me. So that's the write an algebraic expression. So now I'm going to substitute in, I got 2 3-run home runs and 4 2-run hit, or 4 hits that each scored 2 runs. So 4 2-run hits. So that is 6 plus 8. So I got a whopping 14 runs in that game, in that scenario. So create the algebra. That's this part right here. And then evaluate it with the real numbers. I've kind of picked the hardest one that I knew you would encounter so that you can have that one in your notes. All right, and then we're going to wrap this up. We're going to simplify by combining like terms. Remember, it has to have the same variable with the same power. So I have 6 R's and 4 R's. That gives me 10 R's. And I have 3 S's and 2 S's. When I add those together, it gives me 5 S's. Usually we alphabetize. So the R's come first and the S's come second. So in this situation, I have 5 plus 4G minus 7. I'm just going to distribute out the plus to get rid of my parentheses. 5 combines with negative 7. If I have a negative value, the minus sign attaches to whoever is to the right of it. So in this case, I know it's sometimes you want to just ignore the minus sign. But in this case, I have 5 minus 7 is negative 2, and the 4G has nobody. And usually when we're writing this in standard form, we put the variable first and our constant term second.